Hello and welcome everyone. Good morning all of you. Today's topic of discussion is climate change, and we have Dr. Shimray with us. She is assistant professor, associate professor from Department of Education in Science and Mathematics, NCERT. Welcome, ma'am.
Thank you.
Welcome to the program. So my first question is, what is climate change and why we are talking about it?
Well, climate change is changes that we are seeing in the climatic conditions, especially of late since after the Industrial Revolution, all the changes that's taking place drastically. So we talk that in terms of climate change. It's a very complicated thing to define it as such, and so we'll be discussing more about the details of climate change as we proceed with the discussion. But why it is important is undoubtedly I would say that climate change is the most pressing issue that is facing the world today, and so we need to be talking about it more and more so that more and more people are aware of it. And we know of so many people around the world already facing the problem of climate change, impacted by climate change. For example, people in the Bangladesh facing impact of climate change because of sea level rise. We also heard about or continuously hear about polar bears and all losing their place of habitat or place of hunting and stuff like that. And so it's so important that we talk about climate change. Even in India, the government of India, the Ministry of Environment and Forests, mentioned in one of its reports saying that climate change is going to impact India in a very big way compared to any other countries in the world. And so that's the reason that we are discussing this topic of climate change here today.
So you're saying that this problem came after Industrial Revolution?
The climate change as such has been happening because it depends upon the glaciers. We talk about the ice age and so on and so forth. But the climate change that we are talking today is because of the impact of human activities, and so that started after Industrial Revolution, that is after late 18th century, like after 1750s, and so that's what we are talking about when we are talking about climate change today.
So can I say that it is basically man-made problem?
Yes, because we are talking about climate change today because it is man-made or human beings are contributing to it. Otherwise, there has been changes in the climate over the centuries, over the millennium. So it's nothing new, but now why we're talking so much about it is because human beings are contributing to it in a bigger way, and the more we are industrializing or the more we are emitting carbon into the atmosphere, then there will be more of changes that we are seeing today. And that is the reason we say climate change is happening, and it's happening right now because of human intervention.
How much problematic it is? Like, do we really very much concerned about it?
Oh yeah, we should be really concerned about it because I mentioned a few examples about how people are being impacted. And we are going to be more impacted, especially India. India, we are totally dependent on agricultural products, even though we say that we are not really agricultural based right now because we have industries, different industries coming up, different sectors growing. But still, a large proportion of our population is still agriculture based, and much of our economy is dependent on that. And the impact of climate change is going to hit us hard, and so it's going to really impact our economy and the livelihood of so many people, so many farmers throughout the country. And so that's how important it is for India especially to be taking care of this issue.
So it is having a wide range of problem, including the melting of sea glaciers and this agriculture and all.
Yes, and so what happens is it's a complicated thing. Like, it's not as simple as climate change. Like, it's not a straightforward or a linear thing that, okay, this happens and so this happens, but it's more complicated than what it is. And so, and that is the reason people are finding it so difficult to understand climate change as such. And so that is the reason we need to talk about it more elaborately so as to understand it in a better way, so that only when we understand, then we can really feel the need to take some action towards it to tackle the problem. And so it's a complicated issue, and it involves many things in the system. And so yeah, it's hard to just say that climate change is impacted by this, and so if we do this right, everything else will be fine. It doesn't work that way, because it involves so many things in it. It involves the atmosphere, it involves the water, it involves human beings, animals, ecosystems. So many things are involved in the cycle, and most importantly, it involves the sun, from which drives all the system together. And so, yeah, it's complicated.
So it's really a global problem, but is all the countries are trying to solve this problem?
Yes, recognizing the importance of this issue, the people world over have come together, and so we know about the IPCC, or the Intergovernmental Panel on Climate Change, which was set up under the aegis of the United Nations, and so in 1988. And this IPCC was specially set up to tell the world what exactly is happening with the climate, and also to tell us how much it's going to impact our economy, or it's going to impact us. So IPCC was set up specially to look into that, and we're so dependent on the reports the IPCC comes out with every now and then, and the world looks into that report and takes decision based on that report. And besides the IPCC, we have all kinds of treaties, like the United Nations Framework Convention on Climate Change that was started during the Earth Summit at Rio in 1992. Then we also had the Kyoto Protocol, which requires the countries to reduce greenhouse gas emission. We also have the latest, the Paris Agreement that was decided during the COP21 meeting, that is a conference of parties that was held in Paris in 2015. And so it was decided that we are going to limit our emission of carbon, or we're going to limit our this global warming below 2 degrees Celsius, comparing it with the pre-industrial era. That is, if the temperature was like 16, average temperature of the world was like, if it was 16 in pre-industrial time, then we want to limit it to 18. Like, we don't want to go beyond that, and if possible, we want to restrict the rise in the temperature to 1.5 degrees Celsius. And so this 1.5 doesn't sound much, doesn't sound really big, but it impacts a lot. Even slight change in increase in the average temperature is going to impact a lot the world over.
Most probably people do not understand ki, is it really affect like 1 degree Celsius or 2 degree, whether it will really affect on us. Most probably most people do not understand it.
That's right, and so that makes it really complicated to convince people about climate change. That then they will ask us, that people will tend to ask people, experts and all that, so how much is changing? Like right now it's like, it's even less than 1 degree Celsius, like 0.8, 0.9 degrees. The climate change that we are talking about is increase of only that. But we can already see this impact of only that kind of change that's happening. And so if we go towards, or we go beyond the rise of 2 degrees Celsius, then we cannot even imagine what's going to happen. We'll be like all drowned, and we cannot even imagine. That's the simplest way I can put it. And so it's really hard. And so when countries are not taking right steps in this direction, then it's a really worrisome thing for the whole world. For example, the United States recently declared that it's going to pull out of the Paris Agreement. And that's a real concern for the whole world, because United States, as we all know, the per capita emission of carbon, or the greenhouse gases, is highest even today. And so if they are pulling out of the agreement, then it's a concern for the world. And so everybody is now looking, confused, or now worried what's going to happen if United States really actually pulls out of the Paris Agreement. So they're still hoping that maybe they will not do so, but that's what they have announced, that they want to pull out of that. They're just waiting for the right time to pull out, because they cannot pull out of that agreement because they have signed it, and so they cannot do that immediately. So they're just waiting for time for the opportunity to pull out of that agreement.
So you said that they emit highest as compared to...
They emit the highest greenhouse gases in terms of per capita, that is per person. In terms of if you calculate the total emission rate, then yeah, India and China are catching up really fast. But if we talk about per person, how much a person is emitting greenhouse gases, then they are still at the highest spot. even today.
What is our number?
Our number is like, I would say it's still very low compared to the United States, but in terms of overall production or overall emission, then we are like somewhere in maybe in third or fourth position, something like that, or even second. But we are still behind China. Yeah. But I hope we are not competing with China in terms of that. That's not a good sign.
Nobody should compete in this thing.
We should compete so as to reduce towards reduction. That should be the competition, and not towards emission of that.
Right.
So that should be the approach. And India is doing quite a lot, but maybe we need to do more. Yeah.
Better than other countries?
Yes. Yeah, I would say that India straight away jumps into all the agreements that's being signed internationally. Like, we do not lag behind when it comes to taking decisions. We are ready to help, contribute, or in terms a positive contribution like reducing emission. We don't mind, even though, as you know, India is a developing country, and for a developing country, what we require is we need more industries. More industries, as of now, it's like producing more carbon, emitting more carbon. But we are also trying to increase our use of renewable energy. And so that's going to reduce our emission of carbon into the atmosphere. And so India is taking different steps in the right direction, I would say, but maybe keeping in view that we are going to be really impacted by climate change, we need to be doing much more, and even other countries should be doing much more. Because there are so many countries, like the small islands, they're already impacted. They are already now talking with other bigger nations of like rehabilitation, like migrating the whole population from that island to another country. Like, things are being worked out now. So that's the impact of climate change that we see all around the world. But the thing is that unless we are impacted individually, we don't really care about those issues. So that's the biggest hurdle for us, or a challenge for us, for educators to convince people that, okay, it's really important for us to take this issue seriously and take some action towards it, because everyone can contribute in solving the problem. I don't say that if I do something, the problem of the world will be solved, but I can do something from my end. So that's important. And if everybody starts doing, every country starts doing, then why not? Why should we not be able to solve, or at least adapt, or at least to address some of the issues that we are facing related to climate change? But climate change, temperature is going to rise, that's no doubt. Whatever you do, it's still going to rise, but we are what we're trying is to limit the rise of temperature. So we don't want it to go beyond like 2 degrees rise, 2 degrees Celsius of temperature rise. So that's what we are trying, and as of now, we're not sure if we will be able to do that, but let's hope that we're able to do that.
It is not just increasing the sea level, but it is also affecting agriculture and different life forms.
Yes, and so when we talk about climate change, the impact is a sea level rise, and all kinds of impacts are there, like rainfall, like drought. There'll be everything is impacted. Like I mentioned about the changes in the atmosphere, changes in the ocean currents, if there are changes in the ocean currents, or if there is change in the temperature, then it will be impacting the rainfall, precipitation. If rainfall is impacted, then definitely people who are farmers, who are dependent on rainfall, they will be impacted. And so it's a really complicated, very complicated issue, and it needs a lot of understanding to really address this issue.
I also read somewhere that this summer was hotter than all previous summers.
Yeah, we do talk about that, but that's not the right way of putting climate change. You cannot say that because this year it's really hot, and so there is climate change. So that is a variability that we say when we say that temperature is changing. So last year it might be colder, or it might be warmer. This year it might be colder or warmer. But when we talk of climate, we don't talk in terms of year, or individual year, or a few years. We talk in terms of many decades. Like, we take the average of temperature, for example, for 30 years or so. So 30 years is a standard year that we use for calculating the climate. And so only when things are happening consistently, persistently over the years, over the decades, then only we say that, okay, this is climate change. this is the change. Otherwise, it's just a variability that things are changing. It can change. Next year can be colder. And you won't say that now there is no climate change just because one year is colder. And so those are the misconceptions people have. So it's not about what is happening last year or this year, but it's about what has happened over decades. Like, so that's how we refer to climate change.
So what are different parts of climate system and how we can study them?
Yes, when we talk of climate change, we start trying to understand how a climate system works. And the climate system, when we say climate system, then we consider components like the hydrosphere, the atmosphere, then you have the cryosphere, then you have the biosphere, then you have the lithosphere. And so all these spheres, and where human beings and animals and plants are also part of that. And all these pairs, things are interacting there. It's a complex interacting system, and it keeps on interacting. And all these components are, the driving force of all these components are the sun. It is the sun. And so the sun provides the energy required to drive the climate system. And so maybe we can look at one of the slides where we can show how the climate systems, yeah. So if you look at that slide, you can see all the spheres there. You can see hydrosphere. So then you can see the cryosphere, that is the frozen part of water, frozen water, you would say. Then hydrosphere, when you say hydrosphere, then it's a liquid portion of the water. Then you say the land surface, the lithosphere, or the biosphere, and the biosphere, then the atmosphere. And so all these spheres are interacting between each other. And in the atmosphere, as you know, there's so many different types of gases, like the nitrogen, which is about 78%. Then you have oxygen, about 21%. Then you have carbon dioxide, about 0.4% or so. So it's very little compared to other gases, the carbon dioxide. But the atmosphere is composed of many different gases. And so all these gases and the spheres that we mentioned about, the hydrosphere, the cryosphere, biosphere, the lithosphere, and the atmosphere, they all interact. And the sun, as you can see here, it's a driving force of this. So it drives this whole system. And so how it drives is, maybe we can go to another slide again to understand that. Yes, before we get into how exactly the system works, it's important. So when we say the sun is a driving force, so what is this driving? So what exactly the sun is emitting? Like when we say the sun radiates energy, and so it radiates energy in the forms of different, like you can see the different wavelengths in there. This is the electromagnetic spectrum. So sun rays, when the sun radiates energy, then it comes in different wavelengths, like, and what we receive on the earth is mostly in the infrared or the visible light, this wavelength. And so this is what we get. And ultraviolet rays, as you all know, it is being filtered out by the ozone layer in the stratosphere, and that is the reason that we don't want to lose ozone layer, and that's a different topic for discussion, so we'll not talk about that. So what is important here is that when we say that the system, the climate system is the driving force of the climate system is the sun, then we are talking about the radiation that comes from the sun that is reaching the earth, and that which is mostly in the infrared and visible light, this wavelength. And so maybe we can just go to the next slide now.
I'd like to stop you here for some time. We got a question from our viewer, and the question is how climate change and sustainable development are related.
Sustainable development, again, it's a very big topic. Sustainable development includes almost everything. You want to sustain everything. It could be, even education could be sustained. So everything, so it's a very, very big topic. And so if climate is, as we said, mentioned about how economy is going to be impacted by climate. So if economy is impacted, then the whole development thing will be impacted. And so it's really hard to put it in a simple sentence, but yes, they are very much correlated to each other. And so the more we play around with the climate, sustainability is farther away from us. That's the simplest way I can put it.
The more the climate change will be, the more it will affect the productivity of the crops.
That is one point. That is one way. And not just that, the whole thing is everything will change, like the ecosystem will change, the ecosystems like the plants, animals, and so It's very hard to explain things in a very linear way, as I told you that it's a very complex system, and so it works in a system, in a system, like it doesn't work individually. So the whole system will be impacted by climate or changes in the climate, and once things are changing, I mean the climate is changing, then it's going to impact everything, everything in the sense that even food production, the simplest example, then habitat. So where do we live, where do animals live, and when there is drought, then people will start migrating because they cannot live there in that place anymore, or the farmers will give up the farming and they will move somewhere else. Then they will come to the cities for employment or for labor, whatever it is, for livelihood. So then the impact will be felt in the big cities again. And so sustainable development will be farther away from us if we play around with climate more and more. So the more the climate change, the impact will be more, and the more the farther away will be from sustainable development.
So I would like to say to my viewers that it's a live program, so you can ask question in between the program. You can email us, you can call on our toll-free numbers, or you can also write in our Facebook page. And if the question is related to our program, and then we will try to include it. Ma'am, the thing is, so how this balance came, as you said that sun is the major energy source for us, for entire life forms of planet. How the energy balance in this and system balance works?
Yeah, and so maybe we can go to the next slide. I think I have a slide for that. Yeah, so if you look at the slide, you can see, as I said, as we just talk about the radiation or the the infrared and the visible light that is reaching the earth. So when the sun radiates energy, then some of it will be reflected back to the space, and some of it will be absorbed by the atmosphere, some of it reaches the earth. And so when it reaches the earth, the earth absorbs this radiation from the sun, and the earth, when I say the earth absorbs, I mean to say the soil, the water, the plants, animals, everything that is on the surface of the earth absorbs that radiation. And so after it absorbs, it also radiates again the energy in the form of infrared radiation now. So when it is infrared, that means that it is emitting in the form of a warmer, I would say, radiation. And so that keeps Earth's surface, around the Earth's surface, warm. It is because of that. And you also can see this atmosphere surrounding the Earth. So in the atmosphere, as I mentioned, there are different gases. Of those, some of those gases are called greenhouse gases. And what these greenhouse gases does is, they do not allow all the infrared radiation to pass through it, so that it goes out of this atmosphere and into the space, outer space. Instead, what it does is, it traps those infrared radiations and it re-radiates back towards the Earth's surface. And that is keeping the Earth's surface, or keeping us warm, I mean, our surrounding warm. Because of that only, we are able to have a temperature that is livable. Imagine this without an atmosphere. If you remove all this atmosphere, what will happen is that radiation of the sun will fall on this earth. Earth will absorb some of it, and whatever it radiates, it will just go away to the space. It will be radiated back to the space. Then it will be so cold, you know, and so cold, and you cannot even survive on that. And so it will be like, without this atmosphere around the earth will be just like a ball of ice. So it will not be livable. And so it is so important to have this atmosphere and the greenhouse gases around this earth, so as to sustain life. And so once it is warm, then the temperature is there to now evaporate the water in there. So once there is evaporation, then there is condensation, then there is precipitation, that in the form of rain or snow or whatever. And so things start circulating, or it starts cycling, whatever is there. Even the gases that is here, like the nitrogen gas, the oxygen, or the carbon dioxide, they circulate in this, throughout this the different system. Like we can talk about some of those cycles here, if time permits.
What are those greenhouse gases?
And so one very important greenhouse gases like carbon dioxide, we mentioned about that. Another greenhouse gas which is least talked about is water vapor, and it is a very powerful greenhouse gas, I would say. So, but just that this water vapor do not stay in the life is not as much compared to carbon dioxide. That's the reason that we do not consider it to be a powerful greenhouse gas. But definitely, yes, we have greenhouse gas, carbon dioxide as greenhouse gas, and that is helping the earth or our atmosphere warm so as to sustain life on earth.
What what will be the different cycles, like water cycle or geothermal cycles?
Yeah, so we call all these cycles that's happening, like for example the carbon cycle that we talk about. So you call all these kinds of cycles where chemical elements are recycled or it moves in a cyclic manner as biogeochemical cycle. And so we have different kinds of biogeochemical cycles, and so this cycle, like the chemical elements, for example the carbon circulate from one form to another, from abiotic component to the biotic component. Like our body is full of carbon, plant's body is full of carbon, they absorb carbon, they produce food through photosynthesis, and so it is not static as such. So it's continuously circulating all these gases, chemical elements, and so it's in different forms, but it is there constantly, and a kind of balance is maintained because of this kind of circulation, this kind of biogeochemical cycle. At the same time, the sun energy driving the whole system, and so things are almost in the balance because of this. So I'm sure it took millions of years to come to this stage. Like things are almost in a balance. Like the sun energy that is coming to the earth, almost the same amount it's trying to, radiate into the outer space so that the balance is maintained. Imagine if all the solar radiation is trapped in the atmosphere, then you can imagine yourself sitting inside a furnace. So that's not going to sustain life. And so what the sun does is it falls on the earth, then it tries to radiate back whatever is falling on the earth to the outer space so that the energy balance is maintained. And so that's how the biogeochemical cycle also works, and maybe we can see some of those cycles there. Yeah. So, for example, the carbon cycle. When we look at the carbon cycle, as you can see there, some of the carbon is absorbed by plants for photosynthesis, that is to manufacture food, and after that it goes, when the plant dies, and it goes to the soil, as you can see here. Then what happens? Then microbials and respiration and this decomposition takes place. Then it gives out carbon into the atmosphere again. So even in the ocean, if you look at it, so pretty much ocean is called a good carbon sink because it absorbs a lot of carbon, and so a lot of carbon is absorbed by ocean. They are the phytoplanktons there, which uses carbon for photosynthesis. Then it also again releases those carbon into the atmosphere again, and so it keeps on circulating from abiotic component to the biotic component, and so this cycle keeps on going. But the problem starts when human influence is more, for example, as you can see here, and like the fossil fuels, increase in fossil fuels, like the net gain here is like, because we have pumped in 9 gigatons of carbon per year, and so if you have added 9 gigatons per year, but you have lost only like some of those, so the net gain finally comes to about 4 gigatons extra carbon is now in the atmosphere because of human interference, because of human activities through use of fossil fuels or industries or use of change in the land use and stuff like that. And so we are now interfering this natural carbon cycle, and so that is causing the problem. Maybe we'll discuss about more of that in later on.
Can I take the final question? Is it affecting this, the climate change affecting the carbon cycle, hydrogen cycle, and geochemical cycle?
Yes, definitely. As I told you, maybe we can just go back to the slide again. This slide. Yeah, same. So what happens is now we have excess of 4 gigatons of carbon. And so if you have excess of 4 gigatons of carbon, that means that it is going to absorb more of, or it is going to trap more of the infrared radiation, and so that infrared radiation, when it is re-radiated back into towards the earth, then the warming is going to increase, and so that's the whole thing. And so maybe it's a big topic again. As I said, we're going to talk about it in different parts, and so in the next episode we'll discuss more about impact of increase in greenhouse gas emission and the impact of that.
It's a big topic and it cannot be covered in 1 or 2 episodes.
That's right.
We'll continue this later. Thank you viewers for watching us, and please email us your question and queries. Thank you for watching, and thank you ma'am. Thank you for
Thank you very much for having me.